Okay, so for part D, this is a chain rule. So basically what we want to do is we want to do the derivative of the outside, so derivative of ln. Well, derivative of ln is 1 over this whole thing. So e to the x over 1 plus e to the x times, now we want to do the derivative of that quantity. So I'm going to do quotient rule. So 1 plus e to the x times the derivative of the top, which is e to the x, minus top times the derivative of the bottom, which is e to the x, all over 1 plus e to the x squared. So now we want to simplify this. Well, this is just going to flip. And over here we have e to the x plus e to the, so that's going to be e to the 2x minus e to the 2x all over 1 plus e to the x squared. Well, these are going to cancel, and also this is going to cancel. And consider that's all to the first power, so I end up with just 1 over 1 plus e to the x. Okay, the next one. So this is actually, whenever you have a variable in the base and the exponent, we do something called logarithmic differentiation. So, because we can't do the power rule, okay, because the variable and the exponent. So what we want to do is we want to get the variable out of the exponent by taking the natural log of both sides. So this allows us to move the 2x to the front. And now what I want to do is I want to take the derivative of both sides with respect to x. On the left side, we have to do implicit differentiation, so that means we're going to have 1 over y dy dx, or y prime, however you prefer to write it. On the right side, we actually have to do the product rule because it's 2x times natural log of x. So we're going to have 2 ln of x plus 2x times 1 over x. Now, I don't want to leave that 1 over y, so I'm going to multiply both sides by y. So I have dy dx equals y times 2 ln of x, and then here I'm just going to have plus 2, because the x's will cancel. Now, because my function was all in terms of x to begin with, I just want to replace what y was. Now, y was x to the 2x. So my derivative is x to the 2x, and then times 2 natural log of x plus 2. And the other one I think you said was 8. Let's see. Oh, this one. Okay, so this one, 8c, we're going to make u equal to 1 plus e to the x. So du is e to the x dx, which I happen to have here. I'm going to change my bounds. So I have u of 0. So u of 0 is going to be 1 plus e to the 0, so 1 plus 1 is 2. And u of 1 is going to be 1 plus e. So now I have my integral is going to go from 2 to the 1 plus e of 1 over u du. Well, 1 over u, when we take the antiderivative, we're going to get natural log of absolute value of u, but we could see both of these are positive, so we don't really need the absolute value. So we want to evaluate this from 2 to 1 plus e. So we have natural log of 1 plus e minus natural log of 2. And that is going to be natural log of 1 plus e over 2. And that's our answer.